Welcome back to Frequency Online Math. So we're talking about equivalent to what? Logical equivalence. So two propositions P and Q are said to be logically equivalent if their truth table are identical. You know what proposition is? Statements, right? So the logical equivalence of P and Q is denoted by P is equivalent to what? Q, as simple as that. So let me just explain what equivalence means using sets. For example, I have set A to be 1, 3, and I have set B to be, let's say, A and D, right? Or let's say A and C. These two sets, right? Set A is equivalent to what? Set B. You can use this symbol or this symbol. Set A is equivalent to set B. Reason being that how many elements are here? Their cardinality are the same. How many elements are here? 1, 2, 1, 2. They are equivalent. Understand? But is set A equals to set B? No. Set A is not equal to set B because we're having 1 and 3 here. And we're having A and what? C here. So 1 and 3 and A and C are not the same, right? This one is alphabet. This one is what? Number. Another example is 5 bags of tomato is equivalent to 5 bags of what? 5 cartons of gala. That's it. But are they equal? No. Gala and tomatoes are not the same. So that's the proper way to understand what's it called? Equivalence. So when they say something is equivalent, you know what we are saying. So under truth table, right, we have this as P. Okay, we have example. So that the proposition P implies Q and Q implies P. And P if and only if Q are, this is a biconditional statement, this is conditional, are what? Equivalent. So this for this, we are going to represent the other one with P, Q, and P implies Q. So see how you are going to put it. Truth, truth, false, and what? False. If you remember. The reason why it's just 4 is because we're having two propositions, right? 2 to the power of 2 is what? 4. If we're having three propositions, what will it be? It will be 2 to the power of 3, which is what? 8. So we have true, false, 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 true, 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 false, false, true, true, false, false, like that. So this one will now be true, false, true, false, as simple as that. Now, P implies Q will be what? True, true under P implies Q will be what? True. True, false under P implies Q will be what? False. See, this thing you need to know under this imply is that if you are having true here and you're having false here, it turns out to be what? False. You understand? It's just like an invigilator that is trying to tell you that you can do anything in the exam hall, but once you make noise, I will collect your paper. You understand? So these guys are doing anything they like in the exam hall, but once you make noise, the noise is if you're having true under P and you're having false under Q, it will be what? False. You will collect you people's book. Avidly. If you're having true under Q and you're having false under P, if you are dealing with Q implies P, it will be what? False. So we're having false true. It doesn't concern this guy. What concerns him is if you're having true here and you're having false here, you will tear your book, right? So this one is true. You leave you guys. False, false, true. Now this one is Q implies P. This one is the organa. True, true. You leave you people. Do anything you want. True. False, true. You leave you people. Do anything you want. True. But once you have true under this oga patapata and you're having false, you say no, I will collect your book. You're making nice, good. Now QP having truth for okay, sorry. False, false is true. You can do anything you want. You can do anything you want. So we are through with this table. Hope you get it. Alright, good. So P implies Q and Q implies P will be what? Where is P implies Q? Where is it and this? Now under and don't take any rubbish. He's a very strict guy. He doesn't tolerate any nonsense. Once you started lying and you say the truth, you just assume that everything you said is what? Lie. Once you started saying the truth and eventually at the last you lied, you assume everything you are saying is what? Lie. So that's the nature of this and just bear it in mind. So true, you say goodbye. False true, this one liar, false. You not even allow you to finish what you are saying. You say, my friend, shut up, you are lying. You are saying the truth, lying. And lying at lie. You say, my friend, you are lying. True, you say, good boy, good boy, good boy. There's one of my nephews. He say, Uncle Peter, I want to solve maths. After solving, I'll tell him, good boy. He say, yeah. Yeah, Uncle Peter, tell me, good boy. So, all right, we're having P, Q, and P if and only if what Q. This is a biconditional word. So under P if and only if Q, we are going to have truth, truth, false, false. Remember how we used to do it, right? Good. So we're having truth, false, truth, false. We alternate it, right? So we are going to be having truth. Under this if and only if. Truth is what? True. You understand? If you're having true false, it's false. False true is false. False is what? True. So it's only when you're having truth, P to be true and Q to be true is regarded as what? True. Or when you're having P to be false and Q to be false, we are having what is it called? True. So that is for if and only if. Therefore, in conclusion, P implies Q and Q implies P are is logically equivalent to this. So they are logically equivalent. P if and only if Q. So this is how you know whether they are what logically equivalent because they're having true here, true, false, true. So their end products are what the same. Their end products are what the same. So thank you for watching and may God bless you. Bye bye.